Hey Math 8, welcome to day number 2 of my quarantine here at home. So today we are going to continue in chapter 12. I'm going to give you, if you're at school, you get class time to work on this. If you're at home, I don't think it'll take any longer than a class to work on this. Chapter 12 is about using the Pythagorean theorem for triangles, using the Pythagorean theorem to find the distance on a coordinate plane, and finding the volume of various figures. Yesterday we did the volume of a cylinder, and today we're going to talk about the volume of a cone and how it compares to that of a cylinder, and some things to do on your calculator to make sure that the calculator will give you the answer you want it to give you. All right? So let's get started. Here we go. We're going to take notes again. Shouldn't take too long. Notebook paper. There we go. And again, try to make these neat for me, please. I will get them at the end of the chapter. All right. So, if you could label these notes as notes section 12.4. Here we go. So the first thing we're going to do is talk about a cone, what a cone is. All right, so a cone has only one base, and that is a circle. I should say that we are only going to deal with what's known as a right cone. I will show you what that means momentarily. So a cone only has one base. It's a circle. I guess I meant to put a comma there. And smoothly comes to a point at the other end. So a cone has only one base, it's a circle, and smoothly comes to a point at the other end. Pretty easy to draw. You could just draw a triangle without putting the bottom on. And at the bottom you kind of draw an oval. That's makes it look three-dimensional, even that bottom's really a circle, but the oval makes it look three-dimensional. Some people even make this a dashed line back here to make it look more like it's hidden behind the cone. Or you could draw the circle first and the triangle on the bottom. So more of an ice cream cone maybe instead of like a witch's hat. But the thing I want to talk about first is the circle. Alright, so I'm just going to draw a circle over here. Now, the important thing about this circle is, R, it's what we learned yesterday, from the center to the edge. The important thing is the radius. But today on Delta Math, they are sometimes going to give you the circumference of that circle. Circumference means perimeter. It's the distance around the circle. Now, that's a good thing to know sometimes, but in our case, we really just want to know the radius. And so what you're going to need to know is the formula for the circumference of a circle. And that formula is 2 times pi times the radius. And I will show you in a little bit how we're going to use that to help us get the radius. Alright, so that's number 1. We have the definition of a cone, and we have the formula for the circumference. Alright, the next thing I'd like to do is compare a cylinder versus a cone. So we're going to draw two of these that are basically the same size. Right, there's what we drew yesterday, the cylinder. Today we're drawing the cone. And we're comparing these two things, right? And here's what we have to say about that. The volume of a cone is 1/3 as big as, let's see, we'll say 1/3 as big as the volume of a cylinder with the same base and height. So the base has to be the same, which means like if this has a radius of 4, then this has a radius of 4. And the height has to be the same. So if this has a height of 10, sometimes to draw a height on a cone, they draw it down the middle like that with a dashed line. And it has a height of 10. So if you have a cylinder and a cone, and they're the same size essentially, then the cone is 1/3 as big. Or if you said it the other way, you'd say the cylinder is 3 times as big. Alright, that's all we need there for the moment. We are now ready to look at the volume of a cylinder. So the volume of a cylinder looks like this. Volume equals, well, since the cylinder is the cone, I said cylinder, oops, my bad. We did cylinder yesterday. Cone, sorry about that. The volume of a cone, since the cone is 1/3 as big as the cylinder, its formula is 1/3 times the area of the base, which is the circle, times the radius, I'm wrong about that, times the height. That means that 1/3, now this area of the base, so the area of a circle, we went over this yesterday, is pi radius squared times the height. Or if we put that all together, that would be 1/3 pi r squared h. Now, some people do not like to multiply by 1/3. They think that's kind of difficult on the calculator. So what you can do instead of that, the same as multiplying by 1/3 is dividing by 3. You can put pi times the radius squared times the height, and then divide by 3. That is your formula for the volume of a cone. Alright, I'm going to do an example here, and I hope you'll follow this, please, because I'm going to show you a couple tricky things that might happen on Delta Math. And I think I'm going to go to the back so I have room to spread it out. So my example is simply going to say find the volume. Alright. And here's my cone. So I'm going to draw a fairly large one. I'm going to do one of these cool things down the middle of the cone, which makes it look like the height. And I'm going to say the height is 8. And I'm going to tell you that this cone has a circumference of 12.1 centimeters. So we'll make the height in centimeters also. Alright, so I want to find the volume, and I have the height and I have the circumference of the base, or of the circle. Alright, well if I want to find the volume, remember, volume is equal to pi r squared h, and then either times a third or divided by 3. I need the radius. I also need the height. I mean, those are the two things I need to find the volume, the height and the radius. Now I have the height, but I don't have the radius. So I'm going to use the circumference to find the radius. Remember from earlier in the notes, circumference is equal to 2 times pi times the radius. And since I know the circumference, I can substitute that in here and say that 12.1 is equal to 2 times pi times the radius. And now I want to show you something. Well, now we want to solve for the radius. There's a couple ways you could do this. What I'm going to do is I'm first going to divide both sides by 2, so that pi times the radius gives me 6.05. And then I'm going to divide by pi, and that'll get the radius by itself. So on my calculator, I need to do 6.05, a little bit lower so you can see this a little bit better maybe. 6.05, and I want to divide that by, and I'm going to use the pi button again. You want to use the pi button on your calculator so it doesn't round it off. And I get 1.9257 and some more. Now, I'm just going to leave that on my calculator, but I want to show you a couple things. Let me see if I can get this over here where you can see it a little bit better, maybe. Okay. So some people are tempted to do 6.05, oops, not that. Some people are tempted to take this 12.1 and divide it by 2 pi all at once. And if you want to do that, I want to show you something. So if I started with 12.1 and I divided it by 2 pi, you'd think that would get me the right answer, but it doesn't. Instead of 1.9, it gets me 19. If you want to do this in one step, if you want to do this instead of dividing by 2 and then dividing by pi, you could divide by 2 pi, but if you're going to do that, you need to put the 2 pi in parentheses, like that, so that it divides by the whole thing, right? Instead of just the 2 and the pi separately. And you can see now that it gives me the correct answer, the 1.925 and such. Alright, so that's one thing. I now have the radius. I'm not going to clear my calculator. I want to show you one more thing. So now that I have the radius here, I can go here and get the volume. The volume is equal to pi r squared h all over 3, or pi times 1.925 and some more numbers there, squared. That's the radius squared times the height, which is 8, all over 3. So I would like you to write down the formula like that when you do this, but you're going to do it all on your calculator. So your calculator will do this as well as mine. What I'm going to tell you is leave the answer on your calculator instead of rounding it off or having to type that entire decimal back in. That is the radius. Now on my paper here, I'm squaring the radius, right? So I'm just going to leave that on my calculator and hit the squared button, right? You have this on your calculator too. It's the x squared button. And when I hit that x squared button, it takes the previous number that was on the calculator, calls it the answer, and it squares it. So that'll be my r squared now. And then I can multiply that times pi, enter, times the height, which is 8, enter, and divided by 3, enter. And my answer is 31.069 and some more. Right? So I just wanted you to see how to do that on your calculator. And now Delta Math is going to tell you to round this to the nearest tenth. So that would be the 0 is the nearest tenth. But we always take that first decimal and we look at the next number. And it's the 6, which tells me I need to round the 0 up. So this would be 31.1. And since it's volume, it would be cubic centimeters. All right. So that is a nice example of how you find the volume of a cone. Good luck. I think you can get through this pretty well, and I will see you next week.